All right, this is 3.6 Quadratic Inequalities. This will be video number 2, and this time we are solving systems of inequalities. So let's start with example number 3. We have y is less than negative x squared plus 3. I don't know what happened. And y is greater than or equal to x squared plus 2x minus 3. Let's list some things. Our vertex to the first equation will be 0, 3. We find it just like we found in the first video. And we know it's dashed because it's less than, not equal to. And it'll be shaded below because it's less than. In the second equation, our vertex is negative 1, negative 4. And we know it's solid because it can equal, it's greater than or equal to, and because it's greater than, we know it's shaded above. Okay, let's graph them. So the first equation, when I graph it, I put the vertex on and graph my other points. And we know it is dashed. And we know it is shaded below. So I'm just kind of marking that for now, but I got to graph the other graph before I do my official shading. So let's go ahead and plot the second graph. Put in my negative 1, negative 4 vertex and my other points. This time I know it's solid. And it says it's shaded above, which would be up there. Now, you shade your official shading where they both would be shaded. Okay, and so that's in between them. And to pick a test point, we're going to pick a point in that shading. So we're going to pick 0, 0. And we need to see if it comes out true. So I test it in both equations. So 0 would be less than negative 0 squared plus 3. So 0 is less than 3, and that's true. Let's try it in the second equation. 0 is less than or greater than or equal to 0 squared plus 2 times 0 minus 3. So 0 is greater than or equal to negative 3, and that is true. So this works. I know I shaded in the correct area. So let's try number 4. Y is greater than x squared minus 4, and y is less than or equal to negative x squared plus 3x plus 4. Okay, in that first equation, find your vertex by first finding x, negative b over 2a, plug it in, find y, and we get 0, negative 4. Now it's y is greater than, it's not equal to, so it's dashed, and it's greater than, so it's shaded above. The vertex of the second equation gives me a decimal, gives me a 1.5, comma 6.25. It's less than or equal to, so it is solid because it can equal. And it's less than, so it's shaded below. And you can get problems where they're both shaded the same direction. All right, so let's first plot our first graph. Our vertex is 0, negative 4. Get our other points on there, and it's dashed. And it will be shaded above, so I'm just kind of going to mark that so I remember. And I'm going to graph my second equation, and it is a vertex at 1.5, 6.25. And this is solid because it could equal it. And it was less than, so it's shaded below. So they're both shaded in towards each other. So there's my shaded region. Now again, I like to pick the easiest points as a test point. So I would pick 0, 0. But just to show you that you can pick any point, instead of 0, 0, let's pick something else. So let's pick 1, 1. Because sometimes 0, 0 won't be in your shaded area. So test in the first equation, 1 is greater than 1 squared minus 4, so 1 is greater than 1 minus 4, which is 1 is greater than negative 3. True. So let's try it in the second equation. 1 is less than or equal to negative 1 squared plus 3 times 1 plus 4. Let's simplify that a bit. 1 is less than or equal to negative 1 plus 3 plus 4. 1 is less than or equal to 6. That is true. So this worked. Our shaded area is correct. So now go to your practice and finish up the assignment by doing problems number 21, 24, 25, and 26.